Michael.
Hey, Rishi, I got to see what. I know.
Recording in progress.
So at least we know that it is negative for sure, because it's a negative number. So I would write down the stuff that I'm writing. I would put this in the correlation box. Right, but our values are used to describe correlation. In the first box, like you see how the subject says correlation, R values, I would put it next to that. So R values are used to describe correlation. They range from -1 to +1. So if it's -1, what kind of correlation is that? Definitely negative. Would you say that it's strong or weak? Strong. All right. If it's -1 or if it's a negative number that's close to -1, you consider it a strong negative, like the one that's in this problem. That's pretty close to -1. Doesn't have to be a whole number. In fact, it probably won't. It'll probably be a decimal. And then the highest R value you can have would be 1. What type of correlation does that represent? Definitely positive, and then someone did say it, a strong positive. So closer to 1 would be a strong positive. You could have an R value of 0. So if your R value is 0, what type of correlation is that? Well, is 0 positive or negative? So in that case, it would be no correlation. If it's 0, exactly. All right, and then the closer it is to 0, the more like weak it is. And it could be weak positive or weak negative. Just depends on the symbol of the number. So like if the R value was -0.25, what would you say that is? Well, you would definitely say that it's negative because it's a negative number. And then because it happens to be closer to 0 than it is to -1, I would say that it's weak. Make sense? So then on the flip side, if I have a 0.4, how would you classify that R value? A weaker positive. Maybe not as weak as like a 0.25 or something like that. But it's definitely not considered strong because it's closer to 0 than it is to 1. Make sense? All right, so then the next one. And I'll have this posted in Schoology too, like the screenshots if you miss something, but do take notes if you don't. So this goes in the trend line box because the type of equation it makes is considered a trend line. So trend lines are all linear functions, meaning they're in what form? Anyone remember? Linear functions? No, there's a specific formula. Good. Y equals mx plus b are for our linear functions. Standard form is like a different variation of that, but slope intercept form is what we're looking for. So basically, I need to be able to find a number to represent m. What does m stand for? Slope. I'm also going to write rate of change because they will use that phrase as well. So be comfortable with both. M is your slope / rate of change. B is your what? Y-intercept. So they gave us the data in a table. Sometimes we see the data like in a graph. Well, in that case, my y-intercept would be wherever the graph starts on the y-axis. Since we don't have that, since we have a table, then we need to just know that your y-intercepts are wherever x is 0. So wherever x is 0, that's your y-intercept, right? I don't have an x of 0 here. By the way, between hours and pay, which one would be the x and which one would be the y? X is hours, so pay is y for your output. Because your pay depends on how many hours you work, right? Not the other way around. So inputs and outputs also part of this linear function. Now, if we can figure out the pattern, we can figure out our slope and our y-intercept. So first, let's start with slope. Do you guys remember your formulas for slope? There's like 3 different ones. Anyone know one of them?
R2 times Y1. X2 minus X1.
Good. You could use this exact formula if you want to. I think there's an easier one for tables, which is change in y over change in x, which they both mean the same thing at the end of the day. So if I can find my change in y, so like what's my change between 18 and 23? What are we doing? We're adding 5. And then going from 23 to 28?
Plus 5.
Good, and then it keeps going. So that's my change in y, is a positive 5 because we're going up by 5. What's my change in x? Plus 0.5, right? It's going up at 0.5. So then plug that in. What's 5 divided by 0.5? Feel free to use a calculator. What is 5 divided by 0.5? 10. So based off of just that, actually, since we know that m should be 10, I already know that red is my answer. Because the other options don't have an m that is close to 10 that I could even consider. If it was close, I would, but since it's not close, I'm not going to. The y-intercept, you can find a number of ways. Since we have a table that has x's pretty close to 0, I think it might be easier just to figure out the pattern. So like if I want to get to 0, this I would have to do the opposite, right? What's opposite of adding 0.5? So what's 1 minus 0.5? And then what's 0.5 minus 0.5? 0. So I'm basically just extending the table. Down here, do the opposite of adding 5. What's 18 minus 5? What's 13 minus 5? And that's my y-intercept. Whenever x is 0, that's your y-intercept. That's why the y-intercept here is 8. Makes sense? Any questions? All right, so let me take a little picture. Let me stop recording. It is true that they are normally used for scatter plots. So if you don't remember what scatter plots are, say like we did a survey or an experiment and got some data, we would plot them maybe something like this. So here's my scatter plot. They are usually drawn on scatter plots. It is a line that should be drawn through the center of the data. So usually it is computer generated. Sometimes you estimate it by hand, but it's important that it goes through the center of the data. Let me retry that because I messed up. It's important that it's a straight line that goes through the center of the data. All right. It's a linear function because it makes a straight line. We use the formula y equals mx plus b, so that's true. It is not important, though, that they touch all the data points. Sometimes they don't even touch any of the data points. Sometimes it just goes right through the center and that's it. So that's that about trend lines. Any questions about that? So they're used to predict values that maybe we didn't gather in our survey. So that's what they're used for. How would you describe this correlation, by the way? Definitely positive, because our trend line would have a positive slope. Would you say that it's weak or strong? I would say like halfway in between weak and strong. The really strong ones would have it where almost all the data points are touching the line. So like what I'm drawing in the green would be an example of a strong positive. Week would be like way less off the line. So I think this one would be a good example of like in between. So questions? All right, so moving on to the next one. And then this one will probably be our last one, but don't pack up until after we go over it. So what is the sum of the residuals for the data set below? Residuals, at least today, we'll learn more about them also tomorrow too. But that formula for residuals is actual minus predicted. So your actual values come from like if you did a survey or an experiment, it's what you observed with like your own eyeballs. So from survey or experiment. The predicted is what you get from your trend line. So in this one, they already gave you the actual and predicted, so we just need to subtract that. So what's 55 minus 75? Negative 20, what's 80 minus 80? What's 95 minus 85? What's 100 minus 90? What's 115 minus 95? And what's 90 minus 100? And then this specific question wanted the sum of the residuals, which you add them all together and you get that the sum is. All right, we'll definitely focus on that more tomorrow, but you're free to pack up. Make sure you take good notes.
I know, but I'm never.